Let's take a look at a situation where we can apply the gravity function to get an answer to a problem that isn't that easy to get an answer to. And I'm referring to the gravity function. I've got this g of t, gravity function g that uses t, and the gravity function is 32t squared. Gravity tries to move objects 32 feet per second squared back down towards the Earth. And for this particular function, g of t, of course, represents the function that solves for the distance that an object will fall at a time of t due to gravity. Basically what it means is drop something, disregard air friction, disregard hitting something on the way down. This function will find out how many feet that object is trying to move due to gravity at a time of t. And t for this function we're going to be using seconds. So our gravity function, 32t squared, is really representing how far an object is trying to fall because of gravity in a time of t seconds. So in order to do this, what I want to do is venture outside and look at a situation where getting an answer to this particular problem isn't all that easy, but maybe by applying this gravity function, it might help us get an answer. So let's head outside. So here's what we're looking at. This bridge behind me is well, obviously comes over this river right here, and it's quite a popular spot in the summer with the kids. On a hot summer day, they like to jump off the bridge and obviously down into the water below. And I've always been curious as far as, you know, what is the height of that bridge over the water. And I've also been curious to kind of have an idea just how fast the kids are going speed-wise when they hit the water. I know that jumping from particular heights can be kind of dangerous. We don't encourage the kids to do it, but it's hard to keep kids out of the water when it's hot in the summer. So what I'm going to do is I'm going to get up on that bridge and I'm going to throw a stone off of it into the water. Nothing real big. No one's swimming today. It shouldn't be too dangerous. I don't think I'll hit anybody. And what I'll do is I'll bring my stopwatch and I'm going to record the time that it takes for that stone to go from my hand, from the bridge, and down to the water. So I'm going to record that time in seconds and see if we can't get an idea just how high that bridge is. Maybe even get an idea just what that speed might be when that stone's hitting the water. So that's what we're going to try to do today. Alright, here I am on the bridge. I brought my stone to throw and my stopwatch. I will be recording the seconds as soon as I let go of this, and obviously stopping the stopwatch as soon as it hits the water. So here we go. Alright, looks like I've got a time here of 1.301 seconds. 1.301 seconds. Hoping we can take that, do some math with it, get an idea of just how high this bridge is, and maybe what speed that stone hit the water at. Well, based on what you just saw with that bridge and that stone, and trying to solve a particular problem using the gravity function, here's what we're actually trying to get an answer to. We're trying to find out how high above the water is that bridge. Okay? Obviously, it was referred to in the video, kids like to jump off the bridge. Well, it might be nice to have some kind of an idea just how high that is. And the other part of the video, the other question that was being asked was, well, what speed does that stone hit the water? That would be a good representation of what speed it is that kids jumping off the bridge are hitting the water. So both of those questions we're going to try to answer, and we're going to apply that gravity function and the time that was recorded in the video. We're going to try to apply that and see if we can't solve both those problems.